All right, problem 2 says consider the paraboloid z is equal to 4 times the quantity x squared plus y squared, where z varies from 4 to 16. So I have a sketch here that's not to scale, but nonetheless gives you a sense of what this surface looks like. Our job in part A is to give an explicit parameterization of the surface, being sure to include the domain of the parameterization. All right, well, for that, we can just jump straight to the vector function. R of xy is x comma y comma z, which is just 4 times the quantity x squared plus y squared. And we do have to do a bit of work in describing the region R in which the points x, y are able to vary. And for that, right, I want to just go back to this sketch here. So if I project my surface onto the xy plane, okay, this inner circle here, this circle in red, right, that's going to be formed by the base here of the surface, that is going to have a radius of 1. Why? Well, because z is equal to 4 there. So if I set z to 4 in this equation, I'm going to get that x squared plus y squared is equal to 1. So this is a circle of radius 1, set it at the origin. And then likewise up here at the top, okay, for this green circle, well, that's where z is 16. So if I set 16 here for z, I'm going to get that x squared plus y squared is equal to 4. And so that's a circle of radius 2. So xy here can vary over this annulus here between these two circles. All right, and then for part B, it says use cylindrical coordinates to give a parameterization of the surface, being sure to include the domain. So for that, pretty similar to what we've seen up to this point. So in cylindrical coordinates, right, this region here uh, can be described as where our radial distance r just varies from 1 to 2, and theta here, that's going to vary from 0 to 2 pi. And so here's our cylindrical coordinate representation, and on the paraboloid, right, whose equation is z is 4 times the quantity x squared plus y squared. Since x squared plus y squared is r squared, we get that z is equal to 4r squared. And so if we set u equal to theta and v equal to r, then z is equal to 4v squared, just using this relationship here on the paraboloid. And so then these equations here just become v cos u, because again, r is v and theta is u. And then we get v sine u for the j component. And then for the k component, which is just z, that's going to be 4v squared. And here, u, which again is just theta, varies from 0 to 2 pi, and v, which is r, varies from 1 to 2. All right, well, that's going to do it. Thanks so much.